Okay, so let's go ahead and continue on. We just got done talking about how the electron configurations, once again, these guys, we're seeing actually lining up or setting up the different groups, remember the vertical columns, on the periodic table. What's going on? So with that, we're going to go through, and we saw this, and you guys started doing some of this on the gizmo. I didn't take you that far in on the gizmo because, well, we're online and we have limited time. So, but with that, ultimately, you can actually use this periodic table to replicate this. Just by looking at the periodic table, you're going to be able to figure out where different things are. So with that, I'm going to show you a case of point of how quickly you'd actually be able to get through and do these things. Let's imagine I want to do the electron configuration for krypton. Krypton's atomic number 36. Okay. So with that, I'm going to do it, and then I'll show you my trick for it. Okay, with that, I know that I'm starting down here with the 1s, and I've got to fill all the way up for 36 electrons, wherever that's going to end up on this whole piece. Well, with practice, you'd be able to do this. And no, the camera is not sped up. That would be the electron configuration for krypton. How did I go so fast? Well, it's actually kind of easy when you look at the pieces. Remember, I told you the ending configurations. We were lining those up. We were figuring out, okay, everything here is going to end in an S2, everything S1. Everything here is going to end in a P2. Well, my trick was simply this. I saw where krypton was, and I knew everything here, with the exception of the freak, everything here ends in a P6. And also remember, I said go ahead and number your periods. So with that, I saw that krypton was in the 4th period. So I said krypton's going to end in a 4p6. That means everything prior to that needed to be covered. Mentally, this is what I did. First energy level goes to an S2. Actually, let's come back to that. No. Okay. Second energy level, there's 2s2. 2, these guys are P6. 3s2. 3, this goes to a P6. Remember, I got to get down here. It means I got to go through here first. So 3p6, I'm over here now. 4, remember these guys were S2s right there. The one thing that was not covered real in depth right here, these guys are the Ds. These are known as 3Ds. Don't worry about the numbering system right now. It's not a big deal. 3Ds, and there's 10 of them, and then 4p6. And basically, I just knew where I was headed, and I was able to fill in all the gaps prior to that. You can get that good with practice, but we don't need to go down that route. We're going to do something a little bit quicker, because in all honesty, we're using this to find basically one specific thing. I forgot to put that one on. We want to know the very ending. That's the piece that lets us know what we have for electrons that are going to be reactive. I know I just highlighted the numbers, but it's actually the ending piece too. And we'll get to where that comes from. What that's called shorthand notation. Now, shorthand notation is a way that we can write the configuration without having to write everything. It goes through and it really shortens it up, hence shorthand notation. Now, to do that, we base it off our noble gases. And the reason we did the noble gases, remember we said all of these guys have a full ring, full octet. Oct means 8. So it's a full 8 electrons in their outer ring. Remember, the outer ring holds 8 total, with the exception of helium, which is 2. So a full octet. Because once we hit this, the very next electron we add, we have to come over here to the next ring. So this is basically our home point that we can actually compare everything back to. Shorthand notation, I've given you the electron configurations for the following. Easy enough to do. The shorthand notation, it's actually a pretty simple thing. You find the element you're looking at. And what you can do is you can ask yourself, hey, what is the last noble gas prior to that element? Well, prior to hydrogen, there is nothing. Okay. So what we would do for hydrogen shorthand notation, there's only one electron there. Its shorthand notation is just where that electron's at. Helium's here. There's no noble gas in front of it. It is the first one. So its shorthand notation is simply that. It's where the electrons are at. But now, when we look at lithium, let me go ahead and put these in. Once again, these do help when you start talking about these things. So if you don't have them on, write them on. That'll be helpful. Lithium is in the second ring. It's the very first element. It's an S1. Okay. On shorthand notation, I don't worry about any of the inner rings. So when I'm doing the Bohr diagram, looking at Bohr diagram, I'm not worried about any of this stuff. I'm looking only at those outer electrons. Remember, those outer electrons are called the valence electrons. Those are the only ones I care about. Because face it, for me to be out in this ring, that means the ring right in front of it had to be completely full. If I would have stopped there, that would have been a noble gas. So with that, if I were to look at the configuration for lithium, well, 1s2 is the configuration for helium, isn't it? 1s2 is right here. Basically, it's the end of that ring. So at first, it's going to seem like it's not really that much of a shorthand. Trust me, it gets better. How you write shorthand notation is actually pretty straightforward. You can use parentheses, you can use boxes or whatever. You're going to take a box and you're going to write the symbol for the last noble gas. Okay. In doing that, that's the equivalent of writing that. So the HE replaces the 1s2. Yeah, I know you didn't save anything, but trust me, it'll get better. At that point, you're going to write whatever's left. So 2s1. I'm going to go back to regular pencil so it's easier to read. Okay, so we're going to have HE in brackets and 2s1. Once again, you can do parentheses. That doesn't matter. Look at beryllium. Beryllium, if we go through and we're going to figure out, okay, what's the last noble gas? I can count backwards to get to it. So 4, 3, 2, hey, I'm over here. The trick I play is very simple. I go up one period all the way to the very end. So with that, it's going to be an S2, which is helium. So once again, I'm going to go HE in brackets. And by doing that, once again, that's the equivalent of writing that. So now I just write whatever's left. For boron, since I know boron's in this period right here, for every single one of these, the last noble gas was helium, up one all the way to the end. So I'm going to put HE in brackets. The only thing that can ever go in brackets is a noble gas. These very last ones, group 18. And I say, okay, by HE in brackets, I've got that. I now write whatever's left. Still hasn't seemed to save us much time. Okay, that's okay. It's going to get there. Now, neon. Neon's right here. And we go through and we got to figure, okay, what's the shorthand for neon? And this is where we have to continue to do the same thing. Okay, we have to go off the last noble gas. So if we go neon to the end, up one, it's going to be helium. I'll show you why we use helium here in a second. First of all, we're following the same pattern. as we have. We go last noble gas, and that's the equivalent of writing that. Now, here's the reason, because sometimes people are tempted to do that. Well, that's correct. We do put a noble gas in the brackets because that shorthand tells us the last full octet. The problem is that's not going to tell you anything. So let's say that I told you I wanted you to give me the definition of this sphygmomanometer. You'll learn more about that later in chemistry when we get to gas laws. And you grab your handy dandy dictionary or Google or whatever, you type it in, and it says see sphygmomanometer. That's all it tells you. It doesn't give you an image or anything like that. You haven't learned anything, have you? You just have the name. Okay, you don't know anything more about it. If you were to just give me any in brackets, we don't know anything about those outer electrons, where they're at. We have no reference. So that's why we can't do that. Okay, hopefully that makes sense. Now, here's where it actually starts saving us stuff. If we look, sodium's right here. If I want to find the last noble gas, I go up one all the way to the end. So now it's neon. So now I can put Ne in brackets. And if I look at the ending configuration for neon, we said neon ends in a 2p6. So by writing Ne in brackets, it replaces all of that. Now I just write whatever's left. So now we're definitely saving some work. Mg is going to do the same thing. Mg is right here, up one all the way to the end. We've got neon again. So, and we know neon ends in a 2p6. So we've got that. If we start going through and go back to some of these guys, aluminum goes through. Aluminum's right here. Hey, it's right next to magnesium. What do you know? So it's going to end in neon. And we're going to then do whatever's left. So 3s2, 3p6. Now on krypton, all right, I worked out krypton for you. Krypton, we're going to go to the last noble gas, which is argon. And argon's going to end in a 3p6. That's one reason I labeled that. So I'm going to go through, and I've got my configuration. I'm going to find 3p6. And everything before that, I can take care of just by putting AR in brackets. Now I do whatever's left. So hopefully that makes sense on how to get shorthands. The one nice thing about shorthand is everything within a group is going to have the same ending shorthand. All of these guys are going to end in an S1. All these are S2. P1, P2, P3, P4, P5, P6, except the free. Here's the one nice thing. For getting an ending shorthand, I look at the number over here, then look at its place over here. So phosphorus is going to end in a 3p3. It's where these cross-reference. That definitely helps things out. Okay, yeah, these are the Ds. It goes D1 through D10. Okay, and that'll come in later. So hopefully that makes sense on how to get into shorthands. From that and how the shorthand actually plays a part of this. We're going to make the next step in a second, going from shorthand to Lewis stop.